Okay, now we start with the differential amplifier. You understand the differential amplifier? They get a two input. This just a symbol. One input, another input, and two output. Okay? And this is the circuitry inside. A differential amplifier is a bipolar junction transistor amplifier that produce output that are function of difference between two input voltage. Okay, so now if you're looking in this circuitry here, that's a differential amplifier with input 1, input 2, and output 1, output 2. Okay, in this circuitry, Q1 and Q2 is a bipolar, and they must be identical. RC1, RC2, collector, resistor must be the same. Okay. And now, what they say here, assume both transistors identically. R1 equal R2, IE1 equal IE2. Okay, you can see that the same thing. They get the same resistor, they get the same transistor, so the current IC1, IE1. Okay, let's see. That means they telling you the current IC/IE will be the same. Okay, and IRE, that means the resistor total in here will be equal IE1 plus IE2. Okay, and they will be equal VE minus to VEE divided to RE. That's how they calculate the total admitter current. And VC1, that means the output here, equal VC2. And they will be equal VCC minus IC times RC, either one or two. And VE, that means the voltage VE here equal, you get the VB minus 0.7 volt for silicon diode. That's what we already get through it. Okay, for this circuitry, you get any question?
Yes, teacher.
Yeah, go ahead.
Could you explain, please, where is the reference in this circuit? The ground.
What do you mean reference?
Oh, for example, because I can see two power supply, right? One positive and one negative.
Exactly.
So where is the position of the ground in this circuit?
That's the route when you apply the circuitry. Okay, then they can draw up more detail.
Okay.
They have to be get a route anyway. But they just show you inside that IC without any connection.
Okay.
That means if you want to connect the circuitry and VCC have to connect to 12 volt or 10 volt, and VEE have to connect to a negative voltage. Okay.
Exactly.
At that time, they showing you the route.
Okay. Okay.
Yeah. And any more question? Anything about this circuitry? It's just inside the IC, not connect anything in the outside.
Okay, Mr. Pham, just one real quickly. In that formula where you got IRE equal quantity VE minus VEE, is it supposed to be VE minus VEE or VEE minus VE?
VE minus VEE.
Okay,
The current going from VE to minus VEE.
okay.
Okay, now you're looking on this one here. When they routed input 1, they routed input 2. When they measure the VC, you can see what's going on. They both the same. You see that? They both the same voltage, VC1 or VC2. Okay. Okay, now you can see for this configuration, sideways connect to VB1, Q1, okay, input output Q1. Now, they connect the sideways to this input here. However, the other input is routed. So my question is, if you apply the sideways into input here, okay, then what the name of the Q1, what is the name for that amplifier? You already learned bipolar transistor amplifier.
CE amplifier.
You get CE amplifier, CB amplifier, CC amplifier. Okay, so now when I connect the sideways into VB1, then Q1 will be what amplifier? You say CE, right?
Yeah, common emitter.
Common emitter.
Yeah.
You understand that correct answer? How come? If you're going back to the common emitter, and you understand the input will be applied to the base, and output will be from the collector. So the collector, you can get also the sideways. However, this sideways will be
Out of phase.
opposite. That's what I want.
So that's 180 out of phase, right?
Right. Just opposite. Input positive, output negative. Input negative, output positive, 180 degrees of phase. And now what can you tell me? What signal in here? What signal at VE? I'm not doing any calculation, but I want to know what type of the signal at this point. At this point right here.
That be a DC pulse?
No. Basically, if you get a sideways at the base, at the F meter,
You get the same.
yeah, you get the same. The thing is, in this case, you don't have any bypass capacitor. Okay? You get that? Second question. Can you tell me, in this case, what the configuration amplifier for Q2? What Q2 is supposed to be?
Common base.
Stevie,
Common
base.
base. If you go back to the common base amplifier, input applied to the F meter and output from collector.
Collector.
And input and output will be in phase. That's what you see right here. You get sideways in phase with the input. Okay, so for you understand, I already given to you here. Sideways connect to VB1 here. Q1 ECE amplifier. Input output of Q1 is inverted. So that's why you get this sideways applied. Output here will be inverted. Okay. For Q2, VB2 is rounded. Q2 is CB amplifier. Input output Q2 is in phase. That's telling you everything I'm just talking about. So when they asking about this configuration, and you're able to tell them what Q1 is, what Q2 is, what the output of Q1 supposed to be, and the output of Q2. That's good enough.
So, Mr. Pham, my only question is on Q2 on the emitter. And it's supposed to be a common base. So I guess I'm having a hard time seeing the input being applied to the emitter.
So that's why you need to go back to the common base amplifier. Okay?
Okay.
In the common base amplifier, input sideways applied to the F meter. That's why this sideway here, go to the add meter Q2.
Okay, I got you now. I got it.
Okay. And the output of Q2 from the collector. Okay.
Got it.
And they will be in phase.
But I got a question, teacher.
Yeah, go ahead.
This function of this transistor is going to change depending of the configuration of the connection that you are going to do in 1 and 2, right?
Yes.
Well, not all the time are going to work like a CV amplifier with the panel connection.
The thing that depends on the input applied. Then you have to understand if input apply VB1 and you say, okay, Q1 is the common meter. That coming out from the one we already learned, common meter amplifier. Input applied to the base, output from collector. And input output will be 180 degrees of phase. That at least you must be remember that. And also, the sideway will be go into the add meter of the Q2. And the output of the Q2 from collector. They will be a common base. For common base, input output will be in phase. We're not talking about any calculation, but we're talking about understanding. So anything confusing, anything not clear, you have to bring it up. If I given you the circuitry like that one here, and I asking you what the name of that amplifier, you couldn't answer. Maybe I have to quit my job. The thing is you not study. You want to be a technician, you must be study. Nothing for free. Only thing you get into this program, you don't have to pay anything. But you have to study, okay? Any question on this one again? If it's not, now. This is the same thing. Only different is now they apply input in the Q2, okay? And that will be telling you what Q2 now will be CE amplifier. And Q1 will be CB amplifier. I already explained to you in here, okay? Sideway connect to VB2. Q2 is CE amplifier. Input output will be inverted. And for Q1, VB1 will be rounded. Q1 now will be CB amplifier. Input output of Q1 will be in phase. Just refer it. Okay, any question on this configuration? Okay, if you're confusing, just go ahead, okay? I want to help you to understand. Okay, now in here, they given you more detail, whatever we already done. They apply the sideway into Q1. And Q1 is amplified, so the output here, they will be inverted. You see that? And also they telling you at the F meter here, you can get the sideway the same on the input here. And the Q2 will be a common base amplifier. So the output will be the same in phase with the input here. And that is how they look like. So if you're looking at the two output, one will be inverted. Okay, one will be in phase. Okay, they will be the same. That will be telling you. On the story, when they apply the sideway into the Q1 and round the Q2. And you can see what output 1 look like, output 2 look like. To me, everything so up here is very, very clear to telling you what output Q1 and what the output of Q2. Okay. Basically, this just a reverted we already talking about. Okay. So now they apply to Q2. So output will be revert input. And Q1 will be the same with the input phase, in phase. Let's see what happened here. Now, normally, you can see the way differential amplifier they draw by the symbol. Inside this one is this circuitry here. Okay. So they apply to input 1. Okay. And input 2, they round it. And the output, one will be inverted, one will be in phase. And the same thing, okay? They apply input 2, input 1 round, and you can get the same. One will be in phase, and one will be out of phase. Most of signal operation, single-ended input. When a differential amplifier is operated in this mode, one input is round, and the signal is applied only to the other input. Okay, so is it clear to you on this one? Or any question? Okay, if not, now see what next. Okay, now the differential input, what that mean? That means in this case, they apply both input one to input 1, one to input 2. However, when you apply input 1 signal, input 2 signal, one thing they must be follow. That means input 1, input 2 must be opposite. Must be. Cannot be the same. Two opposite polarity, our phase signal are applied to the inputs. If you want to using both input, then the signal applied to 1 and 2, they must be 180 degrees of phase. They cannot be in phase. Okay? Now try to see something here. Common mode input. Both inputs are the same phase, same frequency, and the same amplitude are applied to the two inputs. That means you get two signals here. They are identical. In phase, same frequency, same amplitude. The outputs are superimposed and they are cancelled, resulting in zero output voltage. So if you apply both inputs identical, so one will be positive, another one will be negative, that they will be cancelled out. The output will be zero. That's what they said in here. Okay? This action equal a common mode rejection. So normally,
And why would you want that?
okay, normally, when both input get an identical signal, that will be dealt with the noise. The noise, that means the unwanted signal, normally from the outlet of the power. Okay? They radiate the signal. They go to both input, and that's what they call a noise. And you don't want that. Okay? So the differential amplifier try to do, if they look back, they say identical signal in here. They consider that it's just a noise, and they try to cancel that signal. And the output supposed to be zero. Okay? And this what they call a common mode rejection. Now, common mode rejection means that this unwanted noise signal will not appear on the output, the desired signal. Common mode signal that they will be the noise generally are results from the pickup of radiated energy on the input lines from adjacent line. That try to explain to you everything regarding if you get the same signal identical at the both input of the amplifier, then the output will be zero. They cancel those signals. And that's what they're talking about, common mode rejection. They reject the noise at the input of the amplifier. Any question? up to this point. You have to be reading, okay, over and over. The reason they get a 0, they already showed you right here. One input positive, another input negative. They cancel out. So that's why they get 0. So basically the common mode, that is the purpose. Try to reject the noise at the input of the amplifier. Okay, common mode rejection ratio. That's what we call CMRR. The measure of an amplifier's ability to reject common mode signal. A parameter called common mode rejection ratio CMRR, and the CMRR equal AV of a differential amplifier divided to ACM. That means the gain of the common mode. That means the gain of the noise. And AVD means the gain of the differential amplifier. So basically, common mode rejection ratio, that is the ratio between the gain of the differential amplifier divided to the gain of the noise. That means common mode. Okay, where AV, the differential voltage gain, and ACM is a common mode gain. Common mode gain, that means the noise, the gain of the noise. The higher CMRR will be better. The common RR is often expressed in the decibel at this formula. CMRR dB equal 20 times log of AVD divided ACM. And now you know how to calculate the common mode rejection of the amplifier. Also in the decibel. Okay. Now see what next. Example. A differential amplifier has a differential voltage gain AVD up to 1000 and a common mode gain ACM of 0.2. They want to know CMRR. Then you have to express it in the decibel. Okay, now you try to do the calculation by yourself first to see you can get the same with my solution. My solution CMRR equal 10,000. If I convert into the decibel, they will be 80 dB. Try that by yourself first and make sure you can get the same answer. If you get the same at,
Yeah, I got the same
I-
answer.
Yeah,
Yeah.
the same one.
then now you do it for me, number B. A differential amplifier at the differential voltage gain 8500 and a common mode gain 0.25. They want to know common mode rejection also in decibel. Do it that one. Make sure you can get the right answer.
90.63. Did anybody get that?
Yeah, I got 9 points.
So you get the CM, you say 90?
90.63.
No, the CMRR is 34,000.
I'm not talking about dB yet.
Oh, okay.
I'm talking
CMR
about numerical value.
34,000.
934,000.
I'm sorry, 34,000.
34 only.
You get 3,400.
1,000.
34,000. Yeah, it's 8,500 times 4.
Okay, so basically you don't have a number 9, right?
Correct.
That's what you get. And now CMRR in dB. Mr. Smith get 90.6.
6.
Make sure everyone
Yeah,
get that.
Yeah, that's what I got. Yeah, 90
That's
points.
very good.
yeah, it's good.
Not hard to do.
Everybody get a certificate for that.
Okay, now for the common mode rejection ratio, you want that to be bigger number or smaller, and why? Why you want the common mode rejection get a big number as much as we can?
I was going to say you wanted to reject the signals, but
No,
it says the measure of the ability to reject common mode signals. If you want to eliminate common mode signals, you got to amp it up as much as possible. So a higher value is better.
Yeah, the thing is you want the high common mode rejection. The thing of common mode rejection basically the ratio between the gain of the differential amplifier with the gain of the noise. If they equal, they're telling you the noise and the signal will be the same, go to the output. Okay. Now, normally when you apply the sideway input to the differential amplifier, they can be microvolt peak to peak or millivolt peak to peak. However, the noise in the input, they can get a 1 volt sideway. So you cannot see that signal, 1 microvolt or 1 millivolt signal with your scope. The thing is your signal will be buried inside the noise. Okay? So that's why we need the common mode rejection higher. So they allow only signal 1 microvolt peak to peak or 1 millivolt peak to peak able to go to the output. And you can multiply by the gain of the differential amplifier. That means they amplify the signal very, very small at the input. So that's why you're able to see the signal appear at the output. Without common mode rejection, at the output, you cannot see your signal. So that's why you understand the common mode rejection ratio. When you buy the op-amp operation amplifier, they can telling you what the CMRR equal. If the number small, it's cheaper. If you get a very high number, will be more expensive. That means they're able to reject the noise better.
So, Mr. Pham, does that mean those 741 op amps are like the more inexpensive types?
That's not normal. The thing is, 745, 741 op amp really cheap. But they have to using that op amp in your cell phone, in the system. That it cost a lot. You can say for 741 op amp we're using in the lab, in the class. They cost around maybe, I think, about $2. However, inside your cell phone or the system they build, that op amp cost around $100. Quite different.
Can I ask a question?
Yeah.
Conceptually, I remember years ago, I used to have a car stereo. Inside the car stereo, when you accelerate the car, you can hear a lot of noise. After I put an amplifier in, is that the same thing? Is that noise coming through the amplifier? Is that what we're talking about here?
Yeah,
Eliminating that
means you have to troubleshoot it. The thing is that not only amplify, they still get another thing in that circuitry.
You need to buy a more expensive stereo.
Well, it was after I put the amplifier in.
Yeah, amplify, but inside that they can get more circuitry. You make that amplifier. However,
that noise is what we're talking about, though.
Yeah.
Correct?
However,
Okay.
if you measure at the output, you get the signal, you cannot see it. The thing is too much noise. Then that can be caused by the amplifier.
You get a larger capacitor to help clean it up, won't it?
Right. Whatever. The thing is when they design, they already did it. They already tested. So something wrong, maybe capacitor or maybe something else can cause the problem. That's what you have to troubleshoot it.
Okay, thank you.
Okay, you're welcome. And we try to finish that one quickly. Then I have to go to the level to talking about how to do. Okay, this one you can, I just go through it. You can try to think about the solution. Okay, and next meeting we will come back on this one. For the differential amplified circuit show, single-ended output. What that mean?
Only one output.
Exactly. If you're looking in the path, we already get through. They get two output. Output 1, output 2. However, now they're using only one. So that's why they call a single-ended output. Okay, they given AVD 2500 and CMRR 30,000. V in 1 500 microvolt IMF. At the same time, a 1 volt 60 Hz common mode interference signal appear on both input. So if you're looking in the circuitry, this is your signal right here. And this is a noise. Okay? The noise here, identical. They call a VACM. Okay? Now, number A, they determine the common mode gain, ACM, expressed in common mode rejection in dB. And they want the RMS output. Okay? So make sure carefully go through this example. That help a lot. Okay? So I already given the solution here. You can go to the solution and try to understand it or not. Otherwise, next week we'll be talking for the differential amplifier again. Start at this example. Any question? Okay, if it's not, I will be stopped from my iPad. Okay, now I will begin the camera. Okay, the first thing is I need to working on turn on off the equipment. We need it. Can you say something?
Yes, we can see the oscilloscope.
Okay, that's good. Okay, let's see what we try to do. Okay, now you see on the display the scope, right?
Yes.
Okay, so basically, this is one oscilloscope we'll be using in the lab. Okay, that will be a digital scope. Normally in the past, they're using analog scope. I can tell you the difference between the analog scope and the digital we get. Basically, they will be asking you, can we using scope, oscilloscope to measure the frequency? Now, what is the answer?
Measure frequency, yes.
The scope is
ahead. Go ahead.
the scope is used to measure time, and you use the formula to get the frequency.
Exactly. The answer will be no. The scope cannot measure the frequency. How come? The thing is, the scope is a time domain. They vary with the time. So in order to get the frequency, you have to measure the period T. Then you're using the formula F equals 1 over T to
That's a
get the
trick.
frequency.
That's a trick question, Mr. Fan.
Exactly. The thing is, you interview, we just try to make sure you understand. Very simple question. I interviewed too many technicians. Also, I also be interviewed by someone else when I try to get my job. Very simple question, but asking for understanding. Okay, so that is a big difference between scope we get, digital scope. Digital scope, you can measure the frequency. You can measure the volt peak to peak. You can measure the VRMS. That means you get more things. Okay, you can measure period, whatever you want to measure. The reason is the cost for the digital scope more than the analog scope. The thing is, they do like the analog scope, but they get a formula to convert it into frequency and tell you that is the frequency you want.
So it's built inside, right, Mr. Van?
Exactly. That software, they did it. Okay, so that more make the job more easier. Instead you have to do your calculation.
Hey, Mr. Pham, if I could say one other thing. In the lab so far, you had us use digital scopes, but you haven't had us use analog scopes. Is that correct?
Correct. After you're done, you make sure you know how to work with the oscilloscope in the lab right now. And I will be get some for you to do with the analog scope. Then that will be no problem. Okay. For analog scope, you want to measure V peak to peak of the sideway. Then you have to set the volt per division, and you have to count how many divisions in order to get the V peak to peak. However, digital scope, they do it for you. But the very important thing for the oscilloscope digital here, normally we're telling you press the auto set measure. You must be understand what happens if you press auto set measure.
It automatically does everything for you.
Automatically they trigger, they display, okay, what you want.
You can see the sign in the screen.
But the important thing here, when you try to press the auto set measure, then do not try to touch into channel 1 or channel 2 or tab. Don't change anything. Auto set measure, that means scope do it. They ignore whatever you try to set by hand. That is the key point. Okay. When I go to the real oscilloscope, we'll more detail for you. And if you're looking into the scope here, they get input 1, input 2, dual. Normally scope, they get dual. And in here, they get window here. 1, 2, 3, 4, 5. Okay. So this window, you can set to using channel 1. That one you can set for channel 1. And this one, channel 2, or this one, channel 2. That is the first thing you must decide. Which window for input channel 1? Which one for channel 2? That's the first thing you must be setting. The second thing, you must be setting for channel 1 what you want to measure. Is it the peak to peak, or measure the frequency, or measure whatever? And the second one, same thing. What you want to measure. And also that happened to channel 2. Normally, if you know how to do what to do, and you don't care about channel 2, that means you're using only one channel. If they want to measure the input, you connect to the input with channel 1. If you want to measure the output, you connect to the output. Or if you want to measure anywhere in the circuitry, you just using only channel 1, you don't have to using channel 2. That will be normally happen in the company. Not like you do the left volt. The left volt, they try to training to you to understand how to using both channels. But practically, in the company, you can get only one channel. So you can say you can get first window, you measure the peak to peak, second window, frequency, next window, VIMF, next window, period. All of those one will be channel 1, not 2. We don't need channel 2. My question, when do we need the channel 2?
For the math function.
You don't told me. They apply to input channel 1 and they using channel 2 to measure. No. That's not reason why you have to using channel 2. You don't have to follow it. Only thing is you get the answer they wanted, that's okay. So again, the question is when do we need the channel 2?
You want to measure phase angle change differences.
Exactly, that is the one.
Compare, yeah.
Why they want to measure the phase angle? That means they compare the phase of the input channel 1 to the phase of the input channel 2. That you must be connect both channels. Something else.
Math function.
No,
Yeah, the add invert method.
we're not talking about the function of the oscilloscope. Okay? But we're talking about when do we need both channels? And the first answer will be when you want to measure the phase difference between two signals, then they must be using channel 1 and channel 2. I want to know another one.
Maybe, Mr. Pham, sometimes you want to be able to monitor the input and the output at the same time.
That means
So if you want to monitor the input and the output at the same time, one you'll be on channel 1 for input and channel 2 for output.
yeah, if you want it, that's okay, but it's not, really you have to do. You can connect channel 1 into input, then you connect into output. You can see they will be display, whatever you can see. But you don't have to compare. But if you want compare, then you can using channel 1, channel 2, but not necessary. My question is, I still get another one. Who knows?
We use it for the square waves for the time constraints.
No,
Is it the XY function?
no, we don't care about that.
Okay.
How many more guesses do we have, Mr. Pham?
Okay. Now, normally oscilloscope will be only measure a single point, right?
Correct.
One measure at the point A. Then you connect the scope for point A, but the scope probe round must be connected to round. You see that?
Right.
So if I say, I want to measure the voltage across the resistor at point A to point B, then you only measure point A or only measure point B, but you cannot measure VAB equal VA minus VB. So that will be required.
You're saying that you only have to, you're saying that if you got point A, B, and C, and you look at point A, but then you can't look at point B, so you have to put the channel 2 on point B.
That means the thing is, they want to measure from A to B without any route. If they want to measure point A only, you connect to point A, but the scope route must be connected to the route. Remember, scope route all the time must be connected to the route. They're only telling you, scope probe only measure a single point, not 2 points. When you measure voltage across the resistor from A to B, A not, only single A and only single B, you must be using both channels. Channel 1 connect to A. Channel B connect
Channel 2
channel
connected.
2 connect to B. That means you need both channels.
But Mr. Pham, do you still have to have both of those black leads going to ground?
Exactly. Scope, they must be routed on the black one.
Okay.
They must be. So scope 1 shows the signal on A. The channel 2 display a signal on B. So VAB means VA minus VB. That's what you get, the voltage across the resistor. In the analog scope, they tell you how to do. You connect channel 1 to A. You connect channel 2 to B. And now, in analog scope, they don't have a function. VAB equal VA minus VB. That means you take the V at A minus the V at B. They don't have that function. However, they get only a function they call an add. That means they want you to add voltage at A to voltage at B. Okay, but the thing is we're not adding. VAB have to be VA minus VB. So that's why when you connect to VB, they have to telling you inverted that. That means 180 degrees out of phase. So that's why when you adding positive to the negative, same thing VA minus VB. In the digital scope, they get a function V1 minus V2. So they don't need to invert it. Okay?
But Mr. Pham, that sounds almost like the math function.
Exactly. You have to using that function. Okay? When we do it. Okay, now, quickly review on the function generator. Why I have to do it? I already asking few students when I up to the left and look like they not quite understand what's going on. Okay, with the equipment. If you don't know how to operate the equipment, you cannot do any lab. Okay, so this is the generator. The generator will be generate. If you're looking into here, okay, let's see, they can telling you, they can be sideways, square way, okay? Normally, we're using sideways. And also, this is the amplitude. You turn clockwise, they keep increment. And this is the output of the generator. If you're looking into here, you see that is a 50 ohm output impedance of generator. And also on this scope here, they show you, you get, okay, okay, you get the range. You see that? Right here, range. 1 kilohertz or 100 hertz or 10 kilohertz, 1 kilohertz, depending on what frequency you want to your circuitry. If they want 1 kilohertz, you can set it to 1K. However, they want it 3 kilohertz. Then the range must be changed to 5K or 10K. You can go in from 0 up to 10 kilohertz. That is the range. Okay. And when you get the signal 1 kilohertz, if it's not right, you have to adjust that one to get the right 1 kilohertz. However, don't trust this number. Okay? What we trust on?
The oscilloscope.
Exactly. Normally, when I say that, they tell me, okay, they want 6 volt peak to peak, 1 kilohertz sideways. What I'm doing, I connect generator output to the oscilloscope channel 1. And I try to press the auto set measure to see what volt peak to peak supposed to be and what frequency. If the volt peak to peak is not 6 volt, then I adjust amplitude here to get it 6 volt. And if the frequency not 1 kilohertz, I change that guy to make sure I get 1 kilohertz. I don't care what number here. You understand that when you interview, they're not using the scope like a generator like we get. They're using the old one. They don't have a display. How do we know that will be 1 kilohertz, 6 volt peak to peak? Only one can tell you that oscilloscope. Something else we don't care for now here. Okay? When you turn the amplitude counterclockwise down to the end, and basically you see the signal coming out is 300 millivolt peak to peak. However, your program asking for a 100 millivolt peak to peak. Who knows? Tell me what can I do?
You have to use the offset.
Exactly. That means you have to using 20 dB offset. Okay? They show up here. Either pull it out or whatever. So they will be going lower voltage. That's what you know.
Mr. Pham, your pointer, shouldn't your pointer be on the one that says offset?
Yeah. They say 20 dB. Mine not 20 dB.
No, I'm talking about the knob.
Not from here, you have to see.
Yeah, okay.
I couldn't recognize the number. Okay. When we go to the real one,
Yeah.
then you can see. So now, go back to the scope here. When you need to press auto set measure. When do you want to press that auto set measurement?
When you got everything the way you want it and you want the answer.
Okay, then what else? When that means you not press auto set measurement anymore. However, my question is, when you need to press auto set measurement?
You want to refresh the signal that's coming in.
I already there. Everything already there.
Well, if everything's already there, what do you want? Because this thing automatically gives you the answer.
They already gave it the answer, everything.
So what's your question?
That's what I asking you. When do you want to press auto set measure? You already did it.
All the time.
you get everything you want.
You press that if the signal go beyond the screen.
Now, they cannot go beyond. When you press auto set measure, they already adjusted.
Right.
So you don't have to press auto set measure. Right? They already display everything you want.
Correct.
So if nothing's displaying, press auto set measure, try to get it on the screen, and then adjust.
The thing is when you set auto set measure, the scope will be adjust everything you can see. But my question is, if you need to press auto set measure, when do you have to do?
Okay, Mr. Pham, if we're understanding you're right, everything has been set up, everything is okay. We press auto set measure, we look at the screen, and I guess what you're saying, there's something else we need to do, so we have to press auto set measure again?
Yeah, later on, keep going. Then when you want to press auto set measure,
Maybe after you move the probes.
now the probe already there.
Oh, like on the volt division knobs, if you have to change them, then you're gonna have to press auto set measure again to see where you're at.
Now, you only press auto set measure when you're changing something in generator. When they want it now to be 6 volt pitch to pitch 10 kilohertz, then you have to working with the generator, right?
Right,
To get this signal.
right.
And after that, you must press auto set measure for the scope try to re-trigger to display with the update from generator.
Oh, so you're saying like we're working with the scope and the generator and you had to increase or decrease the amplitude or something, and then
You must set press auto set
measure
measure.
every time you make an adjustment on the generator.
Exactly. Every time you change signal, then you must be press auto set and measure so they can trigger to up to date the signal from the generator. You get that?
Got it.
Okay, when you measure from input, then now you measure the output, you can press auto set measure. That means when you're using the scope to measure different points on the circuitry, and you want update to the scope, you can press auto set measure. Okay,
All right.
any question?
Yeah, Mr. Pham, if you go back to the generator, yeah, the generator. I was going to ask a question, or maybe, I don't know if you want to cover it at this time. The section in the box that's called counter and the other section that says sweep. Do we need to worry about those right now?
Which one?
Okay.
Sweep output.
There's one that says sweep and then the one to the left that says counter. And my question is, do we need to worry about those?
No, the thing is, when they get a sweep, that means they try to do like the spectrum, you know, the thing they try to change a certain frequency on the signal, and another one will be a little different frequency.
Okay, then let me ask you this then. As far as sweep goes and counter goes, well, the counter is on EXT AC. So I guess that has to do because we're doing AC. But for those two, sweep and for counter, don't worry about those knobs when we're doing experiments unless you tell us to.
Yeah, the thing is you don't touch on that. Okay,
All right.
only thing is when you're using your signal, not from the generator, then you can connect to the external input. Okay. Okay, this one you guys already know. Scope probe. Okay. Scope probe in here all the time. They get the black one in the round. They must be round all the time. Okay. They connect to channel one, and channel 2. And also scope in here. They get the 1X or how come we get the music?
Mute all the mics, mute the mics.
I mute it. Still. Okay, maybe they come from the camera. No, it is not from my camera, from somewhere else. Okay, that'd be fine. Anyway, we almost run out of time. Okay, now.
Hey, Mr. Pham, real quickly on the on those probes, do you like to work with ×1 most of the time or ×10?
Yeah, what is the difference? I don't understand what the ×1 and ×10 means.
Okay,
Is that
now.
sensitivity?
Okay, you understand that one. That one basically they will got the one division to up to maximum, I believe 8 division. 8 division. If you measure the signal 100 volts, then you cannot measure. Just wait for me. I'm going to turn off something.
Mr. Pham had too much cool music at his house.
The thing is,
You just leave it on. It's a good song.
the thing I'm lazy, so that's why I just tell Google do what I want.
Okay. And Mr. Pham, but in any case, you were saying on this oscilloscope, you have 8 divisions vertical and 10 horizontal, correct?
Right. If
And
you-
then you was going to explain when to use ×1
exactly,
and ×10.
exactly. Okay. So now, if in your scope volt per division, maximum only 1 volt, then you set what 1 volt in here, okay? So you get a 8 division times 5 volt. Maximum will be 40 volt. You cannot measure 100 volt. If you set by 1, that's why they given you a 10. You want to set the scope probe by 10. and your scope also by 10. What that mean? Now X division, they equivalent to 10. So if you set the scope into 2 volts, that means X division will be 20 volts. Okay?
So it's 10 times 2.
Yeah. So that means at division, you can measure up to 160 volts.
Oh, because it's 8 times 2, which is 16, and times 10 is 160.
Right.
Okay.
So that telling you one thing. When the signal is too big, then you better using scope by 10.
Okay.
Normally, we don't have to measure the very high voltage. So that's why we're using by 1. However, by 1 or by 10 doesn't matter. Okay? Normally, you have to make sure if by 1 on your scope probe, then on in your oscilloscope, you must set the same. Otherwise, measure will be get the error.
So the scope probe and the window on the the window on the oscilloscope and the pointer on the probe, they're somewhat synced together, so they know that they're operating as one.
Exactly. They must be same thing. Okay, now I want to show you that one. That program, I wrote it, and they will be installed in on of the lab computer and put it on the desktop. That's what we call OSC help. So when you try to do, you want to say, I want to set X window to design channel. Then you can press number 1. If you don't know, then they can tell you, first thing, press auto set, then measure. Next thing, press top button, then select the source. And now you can press X window to channel 1 or 2 you want it. That means for the people don't know how to do, that's what you need this program. First thing you want to use in your scope, again, you must be set with which window for input channel 1 or channel 2. Okay? If you get a question, let me know. And the next they say, set scope probe to match your probe. Number 2, they telling you, press channel 1 menu or channel 2 menu. Press the button to change on the probe window. You want by 1 or you want by 10 or whatever. Okay, then number 3, you have to set AC-DC coupling. They're telling you here, press channel 1 menu or channel 2 menu. Press the button to change on coupling window. You want DC or you want AC. Okay. Set the measurement. Okay. Number 4. That means on X window, which one you want to measure. First thing they say, press auto set, then measure. Number 2, press the top button, select the type, and then you press each window to select what measure you want. Okay, basically they get everything. Using cursor to measure time. For example, number 5. Press the cursor button on the type window at the top. Select time. On the short window, select channel 1 or channel 2 or map. Using position to move cursor left and right. Read the data in the delta window. So they're telling you a step by step, you follow that exercise over and over. Later on, you get a log. Okay? The last one I want to tell, number 7. Number 7, they say measure unround voltage. Like I already told you. You measure voltage across the resistor from A to B. Then you need this function. First thing, you must set both channels at the same voltage. Then you press the match function button. You press the channel 1 minus channel 2. Then you press the cursor button. In the type window, select voltage. In the short window, select map. Move the cursor to measure the map voltage. Then you read data in the delta window. So that is all of the instruction can help you to do your lab and make sure, okay, you have to using that in order to exercise if you don't know.
Hey,
why
Mr.
really-
Pham, Mr. Pham, this program right here, did you put that on the web?
I will be put it in each lab computer.
But are you gonna put that on the web?
Okay, if you want to put it in the web, I will be putting it on the web for you. Okay, so the guy, so okay, I will be put that in the web, and you can download or whatever, or bring it out. Okay, and now I will begin back to that one. Okay, so now you can see this is the oscilloscope in here, and you already see everything, right? That will be put a measure, okay. Let's see, measure and auto set measure. That for channel 1. They say channel 1. That is for channel 2. Okay. And also they telling you in here. Okay, each window. Okay. So let's see something else that we need. So when they telling you, you want 6 volt peak to peak and the frequency 1 kilohertz. Normally I connect the generator to the scope channel 1. Okay. Okay. So they showing you in this display here a 6-volt peak-to-peak and the frequency 1.05 kilohertz. Okay, if you want to see it better, you can change the time here. Okay. You see that? You can change it, you can see better. However, the value, they're not changing at all. Okay? So make sure you understand how to working with the generator and how to working with the oscilloscope. Okay? And okay, now I want to quickly go to here. Okay, I want to share that. Okay, next week we'll be going to that one here. Okay. Now that one. The first thing they say is the terminal port connect generator to DC-AC waveform circuit block using 2 port connector to connect generator. Okay. If you see on the circuitry, this is a circuit here. Okay, DC-AC. This is the generator. This is the DC power supply. Okay, when you're looking into here, you see the dot here. What that means?
It's disconnected.
It's open.
It's open.
That
Yeah, open.
means the wire broken.
Right.
So if you want to connect like the way they want, you need to 2 port connect here. So the sideway will be go here, going out. That means they want you to build your circuit. Very good design. Either you're using DC power supply or generator, cannot both. If you connect the output of DC power supply into output generator, you cook output resistance of the generator. Okay, so you cannot connect both. Either way, you can go this way or you can go this way. So on your left, the first thing is you must be connect the circuitry they want. This is the circuitry they want. Okay. They want generator connect to R1 and they want the scope connect here and round here. And now, see what they said in here. Okay. Okay, now that's what I want to tell you. Turn on generator. Set frequency to 60 Hz. On the oscilloscope, switch channel 1, vertical, whatever here. Okay, now this is instruction for analog scope. You don't care what they telling you right here.
Right.
Only you care will be, I want to know how many volt peak to peak and what the frequency. Then you can set your generator for that volt peak to peak and the frequency, and looking on the oscilloscope to see is it that the one value. Okay, you remember, ignore any oscilloscope set up here that using for own oscilloscope. Okay,
Analog.
right, analog. Like here, they say connect channel 1 times by 10 probe. Who care? Okay, we don't care on that. But you care about, they say, adjust generator amplitude to produce sideways. Okay, now, this is still for analog scope. They
Mr.
want
And
six
Mr.
division.
And Mr. Pham, the only thing I disagree with you about is on the times 10, you need to make sure the probe and the scope both say the same thing.
Yeah, if you want time 10, but I say I don't care. I everything by 1.
Yeah, yeah, that too, but I'm just saying, they
Yeah, that's what I already said.
Okay,
I 10 have to be scope by 10, probe by 10. And also, when you say after generator, whatever, here, we don't care. We already set it to 6 volt. This is for the old one. Scope probe, okay? We
okay,
don't care. And now they say what peak value. So basically, you press auto set measure, then the scope will be telling you what the V peak to peak. However, if they want V peak, then you have to take a V peak to peak divided by 2 to answer, to enter. Okay?
right,
So now, this is the first one. Okay? So question A, when you measure, you divide voltage, you enter, they say incorrect, something wrong. What can we do? What you think you can do?
Guess again.
That means you already apply, they did play on the scope 6 from peak to peak and 60 hertz, right?
right,
And you measure right here, they supposed to be 6 from peak to peak and 60 hertz.
right,
Okay. And if they're not coming out, answer right, display on the scope. So you cannot do anything. This is very simple. Only thing you can do, you need the lab instructor. When they come, first thing they can do, they already overlook on this circuitry. See nothing wrong. How come you cannot get the output? Then they can get another board AC1 to connect into your lab and try again. And now it's working. That's only telling you the board you are testing, something must be wrong in the circuit board. And the instructor have to do, they have to make a note on that circuit board. So they have to be fixed. Okay, we have to open to get the board inside in order to fix it. Okay, and also for next, I will show you how to build this circuitry. And also connect whatever need. And just a minute. Okay, now I believe whoever done, they already did this one. What happened here? Okay, that means the circuitry connect, and now they remove the port in here and connect the scope, high side in here, low side in here. What the purpose they want to do?
They want to measure the voltage drop across the 10 ohm resistance.
Exactly. They
Current.
want to measure the voltage across the 10 ohm. So if you get the voltage across the 10 ohm, then you're using the formula V divide 10 ohm. You get the current. So basically, you understand oscilloscope cannot measure the current. Okay? They measure voltage only. So if they want to measure the current, then that's why they adding this 10 ohm here. You measure the voltage across 10 ohm, you divide 10 ohm resistor, you get the current. Okay? And that current maybe later on, they can be using for different. Like they want to compare the phase angle between the current and the voltage across the inductor or capacitor. That's why they use it. However, if we want just a value I, you can using DMV, DMM. Set measure IMS. High side connect you here, low side connect you here. They given you the current.
Hey, Mr. Pham, I don't know if you really want to, I don't know if you really care or not, but if you got a DMM, then also you could break the circuit and measure the current.
Exactly. You can measure the AC current, IMF.
Right.
Connect high side here, low side here. Make sure your meter connect to measure the current.
Well, for the current, you got to break the circuit.
Now they break already.
Oh, okay. Yeah.
That's what you can measure by DMM
Right.
current. Then you can get IMF voltage.
Or RMS current.
That's a current.
Right.
Yeah. That you can get a current. IMF.
Mr.
However,
Pham, Mr.
yeah.
Pham,
yeah,
if you use a DMM to measure the current, don't you have to break the R2?
no, they already break it for you.
Well, when you measure the current, the meter
Without
has to
that
be
one, without that one, you have to break the circuit here.
well, when you measure the current, the meter's got to be in series with the circuit.
The schematic shows the circuit broken.
They already showed you the broken right here.
But then the current still can go through R2.
Now they go this way. They go to the meter.
So you're saying that the current going through R2 is minimal then?
Yeah, that means the same current go anywhere here. That's a series circuit.
Right, but then the meter and R2 is in parallel.
And meter and
R2 and R2 is in parallel.
I think I know what Michael's saying, Mr. Pham.
Yeah, I understand.
Yeah.
Okay. So the thing is, that's what I think, but it never happened. Okay. They show you, I agree. That means you connect the meter here, the current going here, they can go here, and they can go here.
So right below the generator, right below the word GEN, you could break the circuit there.
Exactly.
Right there.
Right here.
Yeah, break the circuit.
Break it, but they not allow you to break any circuit.
Well, we're in school. We're in the lab. If you was out in the
You in the lab and the board is not allowed you to break any.
oh, I see what you're saying. I see. What
It
you're,
is the board.
okay, I see what you're saying.
Okay, so the reason they want to get the current on this circuitry, then they can be open here. Okay. So you can see when they get open here, then you want to measure the voltage, not the current. Voltage across the 10 ohm. In order to get the current, you have to divide by R2. Okay, that is the next one we'll be trying to do. And the next one also, when they want to measure the voltage across R1, you connect channel 1 here, you connect channel 2 here, and you want to measure. And I will help you how to do it. Okay.
Just to be clear though, that R2, that's shorting R2, so there's no current going through the resistor R2.
Exactly.
Okay, because
And
that's
then
grounded. Both probes are
Yeah.
grounded.
They will be go this way.
It was confusing when we first got introduced to the concept of breaking that R2 or shorting that R2. So, but it needs to be specific that when you're measuring the voltage, you're measuring
Across.
the voltage across
Yeah.
R2.
Across R2. Otherwise, normally they short it like the wire. Look like no R2. You get that?
Yeah, so the circuit right
Also-
there only has one order of resistance, 2 orders of impedance.
Yeah. Also, when you reading here, see that both channel vertical display 2 volt, select channel 2 invert function on scope and using the add. That means the instruction for the analog scope we not using. Only thing is they want to measure voltage channel 1 minus channel 2. Okay, that's what we have to know how to measure that with the digital scope. Okay, and the last one for this part will be trying to measure the phase angle. This circuitry here, okay, they're telling you turn potentiometer full clockwise, connect generator to this circuitry and set to whatever frequency. And then they say slowly turn potential counterclockwise completely. They say phase shift or not, I don't care. I care about okay. They will be displayed. One for channel 1, one for channel 2, and they want to measure the phase difference. Okay, phase difference. How can we do? That's what I try to teach you. And if you're looking on the display, which one will be leading? 1 or 2?
One is leading.
Channel 1's leading.
Channel 1 leading. They come in first. They leading channel 2. Either they can say channel 1 lead channel 2, or they can say channel 2 lock channel 1. And the way they do calculation here, they calculate the shift difference from here to here, and they're using the formula. I don't want to do that. We can get much better way how to get the angle. Okay? So we'll be talking about that exercise on the real lab, on the real equipment, and help you to get it. Any question?
Good job, Mr. Pham. Thank you.
Thank you. I still work a lot of things. Try to using camera that still get me a problem. Okay. So far, so good. However, if anyone you're working on AC1 or AC2 or semiconductor, you want to asking about which the circuitry you want me to review, then I will be collect that and try to set it up so can review that for the class. No matter what, sooner or later, they have to do anyway.
Can you display the circuit board schematic, the full board as visual reference? It's like, say you're showing the oscilloscope now, but can you show the real lab volt board so that we can see the complete circuit when you're referencing?
Let's see, I want to see, you see the circuit?
Right. So if you're not taking photos and putting it in the PowerPoint, when you're referencing your PowerPoint, can we look at the board at the same time so that we see how the circuit's actually connected?
Okay,
Whatever you can figure out, Mr. Pham. I'm sure you have a lot of things.
I know what you say.
Thank you.
Okay, only thing is we try to find a better way in order to happen to your guy able to understand. Okay, right now, you see, I already get that circuitry and I try to set it up and try to display. I try to copy it and upload it for the guy, right?
Can you put in some type of exercise together when demonstrating the PowerPoint and actually work on the board at the same time, like Mr. Tai was doing?
That's what I still have to asking someone know about this camera.
Right, I understand. Thank you.
The thing is right now, okay, when I display this one, and I cannot display any text file or whatever. So, like, you know, Mr. Tai, he can get display for that one, right? And also he can able to display another one. Like, you know, you try to run through the lab. So they get an instruction telling you what to do. And he do it. So I need to ask, how do I display in the same window for the PowerPoint or the program? That is still another problem. Okay?
All right, thanks, Mr. Pham.
Yeah, no problem. So we will see your guy next week.
Okay, get some sleep.
Thank you.
All right, now, have a good
All
night.
Thank you, Mr. Pham.
Good
Good
night.
night.
Good night.
Good night.
Goodbye.